We continue our lecture. Here we here we need to consider some error. So we'll consider this one. So become this result. So that we need to listen because we consider this some error term. So but we try to reduce the error. So this become this way. The equation will plus reduce because we minimize this one and we allow some error. So we plus the error, but we minimize. Okay, and C is just some constant term. It's scaling. Scaling means suppose this point 0.5. So if the C is bigger, right? C is bigger, so they will become bigger. The C is smaller, they become smaller. And here is also constraint. Okay, so this is a supportive vector machine. But in our deep learning so far, we don't do such complicated. Continue. So here, finally, this is our we call constraint optimization problems. So it's the original equation plus constraint term. And subject to, this is also constraint, subject to this original one. Here, see, this is a kernel function. Because we try to project this in higher space. In higher space, we have this kind of a constraint. So we include the kernel function here. So this constraint will occur in higher dimension. Okay. So originally we only have x. Right now we suppose the x in the higher dimension. But what's the phi? This phi is a kernel function. It's also called our activation function. 就这个，就你要选一个方选，让它投上去这样子。所以kernel function phi 就是这些东西啊。OK， 所以最后的 equation 变成这样子。这还没完哦，因为这个还要并上去。但是这个你就 this is a Lagrange constraint, similar to Lagrange constraint. Okay. Now this is some example. That's meaning if a bigger C, this is small c, bigger C here. That's meaning they will do more constraint. So bigger C, if a C is smaller, will spread out. If C is bigger, there will become some limitation. If C is very big, it will become like a circle. You constrain on this region. C 就是说，当你这个 C， 这是那个当这个 C 的值小的时候，这分两群。当这个 C 越大，它就会把你要的限制包起来。那这样你的其他就不理它了，其他 noise 就不理它这样子。但是问题就是 C 也要调，所以 SVM 有时候要去调很多系数这样子参数这种考试。再继续，这我们跳过去啊，这个你自己再慢慢看。我要讲的是讲那个 Lagrange 这个，就我们刚刚已经有那些这一个 equation 大家是这样确定的，这是 high dimension。那我们怎么把这个变成 equation？ this is basically this is a Lagrange. So we'll go to Lagrange. Lagrange. So the equation for Lagrange is this one. 这是它的条件。So this is original equation. This x is input. F is the original equation. Okay. The G is constraint. Is constraint. So constraint is meaning you want to this become this one. This original constraint, and you become this one. This meaning 你本来是在这里嘛，这有点无聊，你要把这个 term 移过来。它的条件就是这里要大于等于0嘛，所以你要把这个 term 移过来，就会变成Lagrange的东西，变成这样子。所以这是 Lagrange equation. So this term is the constraint here. 是这样子，就是 constraint term. So you need to put a constraint term behind the equation. So this constraint term will become the Lagrange function, and you minimize this function. So your purpose, you try to solve this L. 用微分的方式嘛 ，gradient descent 的方式来求这样子。好，那这个大概就你看变成这样子，式子变成这样。This is your constraint, right? This constraint. So your equation will be original one, and then this is constraint. 但是要移过来，你这边要离这样子，变成这样子，这是借Lagrange。好，这样子这个 lecture 就结束了。后面好像没什么，只是跟你讲而已。那最后就会这样 labeling， 这 labeling 了。OK， 好，这我就不讲了。大概是这样，因为你现在不会用到 SVM 的，只是这个概念很多都用到 deep learning 去了啊。Okay, we'll continue our lecture. So that's it for our computer vision and machine learning. And we'll continue to talk about deep learning. We try to finish this lecture. We'll finish this one. Okay, start again.